Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker, Chapter 13, Part 3, Model Building and Diagnostics, Transformations. Okay, so remember that we're talking about linear regression, and in the simple linear regression model, we have yi equals beta 0 plus beta 1 xi plus epsilon I. In the multiple linear regression model, right, we have yi equals beta 0 plus beta 1 x1 plus all the way down to beta k xk plus epsilon I. All right, our assumptions are that those epsilon i's are independent observations and that they come from a normal distribution with mean 0 and variance sigma squared. We can use our residuals to check the assumptions of the model by taking our observed minus our predicted. And remember that our residual plots should be distributed around 0 and they should have no pattern. If we don't have an adequate model and we see a pattern in the residual plots, one thing you can do is do a transformation, right? So for simple linear regression, we can look at the scatter plot of xi and yi, and then we can look at the residual plot for xi and ei. For multiple linear regression, since we have so many dimensions, sometimes it's just easier to look at the residual plot of the xi and ei pairs. So when we look at our transformations, the goal is to transform our data so that the model assumptions for the regression are upheld. So if you're looking at three main points, which is whether or not there's a nonlinear relationship between our predictor and our response. We can detect that by doing the regression plot between each of our predictors xi and the residuals ei's. And the way we fix that is by transforming x. If we have a non-constant variance, we can detect that by plotting the fitted values versus the residuals. And a way to fix that is by transforming y and even possibly transforming x as well. The last thing we're going to look at is the non-normality of the error terms, and we can detect that by doing a histogram of the residuals or also doing a normal probability plot of the residuals. And the way that we address that is by transforming y and possibly also transforming x. So I gave some common transformations here that you might attempt just to start out. One's a square root transformation, an inverse transformation, 1 over y or 1 over x, the log transformation, and for x's, sometimes you might need to bring some of your x's to a power. And overall, if the correct functional form is obtained, the plot of your xi ei pairs should be centered around 0.